Hi guys, hello everyone. Welcome to today's session. John Bankole, I see you waving your hand. John Bankole is one of our old time buddies. John Bankole has been a part of this channel from the beginning. Uh, hey, Simi Sola, as usual. Simi Sola is here saying hi. Welcome, Simi. If you're in this session, just indicate where you're calling from or where you're streaming from in the chat. We'll give you a shout out on this channel. Today is going to be a very, should I say, a very intensive session with Taiwo today. And we're talking about app containerization and orchestration. So this is the advanced. Oh, Onuchi Abo from Abuja. Fantastic. Great. Keep them coming. Samuel Joseph from Lagos. Fantastic. Welcome, Samuel. Welcome, Onuche Abo. Hey, Noibi. Welcome, Noibi Abdul Razak. Sorry, I maybe murdered your name, but Abdul Razak is streaming from Lagos, Nigeria. John Bankole from Ado Ekiti. Fantastic. That's the only person out of Lagos. Oh, we have Franklin Afolabi from Benin. Fantastic. Welcome, guys. Today, this is the advanced session. We went on a break and now we're back. Yeah, we're back fully packed, and we have Taiwo backstage. We would introduce Taiwo in a bit, but today is about app containerization and orchestration, EKS, Elastic Kubernetes Service. We have Okesanya Odunayo Samuel from Lagos. So we have a lot of people from Lagos as usual. We have someone from Benin. We have someone from Ado Ekiti, which is John. And then we have Franklin from Benin. Oh, there's someone from the United States. Fantastic. Yeah, Brian Watson from Philadelphia, Pennsylvania. United States. Wow, we're going global. And today we'll be talking about Kubernetes on AWS, which is setting up your EKS cluster, which is your Elastic Kubernetes Service cluster. That's what we plan to do today in this advanced session from the AWS DevOps Study Group Nigeria. So without further ado, I'm going to bring Mr. Taiwo on stage. Taiwo, are you ready? Hiya, Taiwo. Are you there? I'm going to bring you up in a bit.
Yeah, apologies. I'm trying to set up my system.
Okay, Taiwo, do you need some like 1 minute or
Yeah,
two
just
minutes?
give me like a minute. I'm just trying to set up my system.
And Taiwo, we need your video too. Just,
My video. I'm just please hold on.
yeah. Okay. All right, guys. We take Taiwo backstage, and I can see some guys in the chat. Edmond Godwin. Hi. God's time. I don't know what God's time is doing here, but I'm not going to greet God's time because God's time is a fellow, is one of the leaders of the DevOps study group. So I'm not greeting you God's time, but anyway, welcome to the channel. All right, guys. So while we wait, we have more people joining. We are just waiting for Taiwo to set things up. So this is going to be a comprehensive walkthrough tailored for Kubernetes enthusiasts. So if you're an enthusiast or you already use Kubernetes, in most cases, you have Kubernetes running on your local computer, or you have Kubernetes maybe running on Azure or some other cloud provider, but this time is all about AWS because we are AWS people here. If you permit me to say that. So this is tailored for Kubernetes enthusiasts, which is covering the setup and then the optimization. That's what we're doing today. And then possibly next week, we'll now have to show you hands-on on how to deploy a specific application to that cluster. I don't know what app we'll be deploying yet, but we are trying as much as possible to create sessions that can help you build your portfolio. It's all about building your portfolio. It's all about getting hands-on experience. That's why we are here. Taiwo, are you ready? Taiwo, are you ready? I'll bring you up again.
Yeah, I'm ready.
Okay, so Taiwo, we would like you to share your video, please.
Yeah, I've done that.
I can't see your video. You have to click on the camera button.
I've done that now. Please apologize. Just trying to set up my environment.
Okay, I still can't see your video, by the way.
Yeah, I'm trying to. I've just clicked on the necessary settings. I think it's my network. But just apologize.
All right, so give me a minute. While we wait for Taiwo for another 1 minute, I'm going to hit you with this very nice hip hop music. So let's just wait for 1 more minute. All right. So we're back. We would get onto it. We've waited for 14 minutes now, so let's get onto it. I'll call Taiwo in. Taiwo, how are you today?
Yeah, good evening. Yeah, coming. Good evening. Apologies for the setback. I was just trying to set up my environment. Apologies for that.
All right, so let's just get to it. I can see someone from Daniel Dongo. Daniel Dongo, yeah, we see you. Idris Shogunle, welcome, sir. Welcome, sir. Franklin, this is reminding me of the music on Slack Holder. Yeah, yeah, gotcha. Ebenezer Kuku from Lagos, Nigeria. Welcome, y'all. Welcome, y'all. Taiwan, I'm going to share your screen and I'll let you do it from here. Bye.
Okay. Yeah, good evening, guys. My name is Taiwo, and I'll be walking you through setting up Amazon AKS. So the first thing is, what is Amazon AKS? So Amazon AKS is more or less like a also the necessary environment you need, more or less like the master and the worker node settings. So now I'll be walking you through what's the process of setting up a proper EKS cluster. Please apologies. I was trying to hold up my. Okay, fine. The first thing we need to actually understand about EKS is more or less like before Amazon came up with setting up, bringing or setting up Amazon EKS. People actually set up the EKS manually, making use of Cube ADM and either COPS. But the big problem with setting up your EKS cluster with that kind of procedure is more or less like there's a lot of complications with the settings, especially your control plane, which is actually your master node. So for a Kubernetes cluster, you have what's something called a master node and a worker node. The master node actually contains the necessary. You contains your what do you call it? Your API servers, your schedulers, your controllers. More or less like it's more or less like the administrative part of your Kubernetes cluster. So anytime you want to probably deploy things on your Kubernetes cluster, you want to interact with your Kubernetes clusters, it needs to actually go through your master node. So what um, AWS is actually trying to do is more or less like all the overheads of you setting up your master nodes. AWS is actually trying to like help you sort that one out. So the only thing you just be focused on is just setting up your worker nodes depending on your configurations. So now, for us to actually start to set up an EKS cluster, the first thing we need to actually do is more or less like we need to actually create an EKS IAM role. So what we need to do now is more or less like, apologies, I don't know why this thing share the screen. Apologies, I don't know. I'm just trying to share screen. Just tell me to share screen everything. Apologies, I don't know. My device is always telling me to share screen every time. I've done that. Apologies, share screen. I've done. Please, please. I'm trying. Okay, fine. So the first thing we need to actually do is more or less like we need to actually create a role. So basically, for us to set up the AKS cluster, we need to start with setting up a more or less like a role that our AKS is going to use for our EKS cluster. So now just start creating. Let's first start. Let's create a role first. So this is AWS services here now. So this is more or less like the okay fine because we're actually working with EKS. We need to come here and type EKS. Okay, fine. So from these selections of EKS, the option we need to actually work with is EKS cluster. This particular one. So what this one simply means is more or less like it actually allows us to actually create our more or less like any form of it actually gives us access to other AWS resources that is going to be required by EKS cluster basically. So I'm selecting this EKS cluster here. Please, I don't know, share screen. I've done that. Please apologies. This I just need to just it's popping up is for me to allow to share screen every time.
Oh my, oh my, oh my audio was out. Thank you, Abdurazak. Can you hear me now? Godwin, can you hear me now? Oh, okay. So, like I was saying, I had to take Taiwo backstage a bit because Taiwo helps us with, yeah. So, as I was saying, Taiwo helps us with working, solving problems on the DevOps study group. So, we have a DevOps study group where the main thing there, uh, can you hear me now? Thank you so much. So on that DevOps study group, the main thing we do is to give people practical hands-on knowledge, right? And in terms of having that practical hands-on knowledge, we're also there to help you in terms of bugs, in terms of support systems, in terms of resources, in terms of opportunities. I'm going to call Taiwo back in.
To use the default VPC because you want to
Taiwo,
actually make use
Taiwo,
of your own
hello,
prepared VPC that has
hello,
a private subnet and a public subnet. So what we can actually try to just do now is more or less like we will try to create our VPC making use of
Taiwo, hold
CloudFormation.
on. Taiwo, can you hear
So
me?
for if you're using CloudFormation to set up our VPC, then we're going to make sure that it complies with the proper EKS setup. So we click on CloudFormation here. So let's call this EKS VPC. Okay, sorry, we're going to create a stack here. So for us to create our VPC properly, there's a documentation here creating a VPC for, yeah, this is creating a VPC for your Amazon EKS cluster. So by default, what you are trying to like focus on is more or less like having an EKS cluster that has a public and private subnet. So this is what we have here now. And for us to use CloudFormation, we can just probably just use this template here. So we just copy this. If we make use of this, it's actually going to create the whole VPC for us, consisting of the NAT gateway, the route table, everything we actually need. So we come here, this template is ready. We're going to use Amazon S3. So Amazon S3 URL. So we paste it here. So we click on Nest. Okay, now so let's just call this EKS. Call this EKS VPC. Okay, fine. So with the CloudFormation template we actually use now, so it has actually given us some parameters and some of the values we might actually make use of. So this is more or less like our VPC block. So that's our CIDR range, and the public subnet. This is our public subnet also here. So if I now probably want to like if I have a particular CID range I want to actually make use of, so I can actually just come here and just tweak it to my own taste. But I'm just going to actually make use of what we have here at the moment. So we click on Nest. So we don't need to actually do much here. So we just click on Nest. So now this, then we click on Submit. So at the moment now we are trying to create our VPC with the necessary resources, more or less like NAT gateway, internet gateway, more or less like we're setting up a proper EKS, a proper VPC that consists of a private subnet and a public subnet. So we need to just wait it out for this VPC to actually set up. So while this one is setting up, it's probably because it's going to actually take some while for this to provision every resource we actually need. So going over what I actually did earlier is more or less like for setting up a proper EKS cluster. For EKS cluster, we actually need EKS cluster consists of a worker node, the master node, master, the control plane, and the worker node. Control plane can actually be called the master node. So the master node actually consists of more or less like the necessary objects inside, the necessary things we actually need for the control planes. So actually, what actually makes a control plane is more or less like the API server, the scheduler, the controller, and things like that. So Amazon is actually going to actually help us to actually Amazon EKS is actually going to actually help us to set up the control plane itself. And when it sets up the control plane itself, it ensures that it actually ensures that it's actually highly available. So what that simply means is more or less like it's going to be provisioned in 3 different AZs. But by default, we can't actually see that. But AKS does that at the background for us. So the moment we set up the moment we set up our EKS, if the moment we set up this particular stuff, the VPC, the VPC, the moment we provision this our VPC, then the next thing for us is actually just for us to just set up a proper, create a proper EKS cluster itself. So let's just wait for this to set up. So at the moment it's creating the route table, the subnets table association, the VPC itself. So let us wait for this to complete setting up. Okay, fine. So our VPC configuration has been complete. So we can actually just come here to check our VPC itself. So let us refresh this page. Okay, so let me select this. Okay, this is the VPC we actually set up. Yeah, so these are our VPC that we used CloudFormation to set up. So looking at subnets also. So this is subnets, the route table, internet gateway, everything has been set up. Everything has been set up here. So let's go back to our CloudFormation. So security group settings that we needed for our EKS has already been set up. This is private subnet, public subnet, VPC gateway, everything has been set up. So now after setting up this, so that means we actually have a VPC that our EKS can actually use now. So what we need to do now is more or less like we just need to go and create our EKS. So we click here, create EKS. So this is where we actually need to create our EKS cluster. So let me call this EKS. Let's call this EKS cluster. So this is the name of our cluster, EKS cluster. Yeah, so this is the latest version, Kubernetes 1.27. Then automatically we need to actually specify a role, one of the roles that we actually created earlier. So this is the role I'm going to actually make use of, the EKS role itself. So we're selecting this. So looking at these other options here, secret encryption. So normally when you're setting up your EKS cluster, you can actually set this on, because secrets on Kubernetes actually base64 encoded. So that means people can, when people actually probably have like access to your clusters, and they get access to some very sensitive part of your Kubernetes clusters, so your secrets will be more or less like vulnerable. So you can actually just click this to actually encrypt all the secrets you have in your Kubernetes cluster. But for now, we're not making use of that. So we click next. So now the VPC we actually created was EKS VPC. So let me confirm the name of the VPC we have here. EKS VPC. This is it. Okay. Okay, this is it. So selecting this. Then the next one is, okay, fine. We need to select this all subnet. So this was the subnet that was created by our VPC itself. Then security group. So this is the security group that was created by our CloudFormation for the proper EKS setup. So now this is a cluster endpoint. For the cluster endpoint, the first option is more or less like public. So what is public, or more or less, means that when you want to connect to your clusters, the cluster endpoint is accessible from outside your VPC. So what this public is more or less like, if you want to actually communicate with your cluster, by default it's going to be public, even if your account want to actually also wants to connect to your VPC. But we don't want institution by, if our workaround is communicating with like our API gateway, we want to ensure that that one should be private. So we're going to select public and private. So with public and private, if I'm trying to connect to my Kubernetes cluster from my local machine, when I run kubectl get port automatically with public, I'm able to connect to my cluster. So with private, so any form of communication that is happening within the VPC, my worker node, and the control plane node should be actually be within my VPC itself. It shouldn't be outside, it should be private. So then we select next. So now the next one is more or less like control plane login. So these are, maybe if you actually want to probably check some logs for your API server, your authenticator, control manager, scheduler. But since AWS is actually managing this whole thing, you don't need to actually click this. But if you are very inquisitive to just see the inner workings of all this, you can actually set it up. But AWS handles all this for you. So we click on next. Okay, so lately EKS just added this add-on. So this is kubeproxy, core DNS, VPC, CINI. So kubeproxy is more or less like networking within your clusters. It's more or less like just like a problem, but just more or less like an add-on. The core DNS also, and the Amazon VPC CINI, so which enables pod networking within your clusters. So this one comes with it by default. So next, we click on next. So this is the setup. This is what we actually have now. Kubeproxy, core DNS. Okay, the next one is just click next. Okay, so this is for our networking part, the VPC, the subnet, and the security group that our CloudFormation sets up. The cluster endpoint access, we are using public and private. So, okay, now, so we create our Kubernetes cluster. So at the moment, we are trying to set up our cluster is being set up. So we need to actually just wait a bit for it to come up. So this is overview, resources, compute, networking. Okay, this is the subnet we actually specified and our VPC, the add-on. So everything we actually created here now is just related to the master node itself. The setup we actually did was more or less like just the master node. So the next thing we're going to provision now is going to be our worker node. So that's where we deploy our applications on. So let's wait for this. This probably takes like 10 minutes to provision.
Hello, Taiwo. Are you there? Can you hear me? Taiwo, can you hear me?
So while this one is provisioning, I think we can actually just use that time to set up, um, start setting up our worker node. But for us to set up our worker node, it's something that we need to actually come here to set up. That's nodes, node group. So while this one is setting up, you can actually go and create roles that our worker node is going to actually make use of. So we come here and create, set up, create role. So now, because our worker node makes use of EC2 instances, so we click on EC2. So when we click on EC2, the options available here are more or less like EC2 allow EC2 instance to call AWS services on your behalf. So we are going to be making use of this. So when we create this now, there are some policies that we need to actually attach. There are some policies that we need to actually make use of. So one of them is EKS worker node policy. So this So when we click on what this policy is all about, it's more or less like you should be able to like describe clusters, VPCs, the volume, the subnet, security groups. So this is one of the policies we need to work with. That's EKS worker node policy. Then the other policy we need to work with also is container registry. So let's select this container registry. So what this container registry is all about is more or less like when you create your ECR. The ECR is more or less like where you deploy your images to. So you want your worker nodes to be able to like connect to it, like pull images from it. So that's why we're actually selecting this container registry. Then the last one we need to actually last policy we need to actually connect is EKS CNI. Yeah, this. So what this does is more or less like it allows communication within your worker nodes. You can actually have different applications on different servers, so it actually allows easy connections for that. So looking at the content itself, EC2 modify network interface, describe interface type, describe network interfaces. So it's more or less like for internet for network interface itself. So these are the three policies we're going to be attaching to the roles we are setting up for our worker nodes. So the next thing we select next. So let me call this worker node roles. So allows EC2 instance to call AWS services on your behalf. So this is the assume role. So these are the policies it's going to make use of. Okay, fine. So let's check our EKS cluster if it has finished setting up. Okay. It's still provisioning. So after the EKS has finished setting up, then we'll probably work on setting up our worker nodes, but we can't do that yet until the EKS cluster finishes setting up. It takes close to like 10 to 15 minutes for the EKS cluster to finish setting up.
Taiwo, are you there?
The EKS should be done anytime soon.
Taiwo, are you there? Can you hear me? Can you hear me now? Taiwo, are you there?
Okay, while we wait for the EKS cluster to finish setting up, the next thing we need to actually do is just set up node groups. There's different options here. There's node groups, Fargate profile. So so for best practice, you make use of node groups because you want to ensure that your nodes are more or less like well arranged. It's not actually ideal to make use of this option. The best option is actually to make use of node groups. For Fargate profile, it's more or less like you making use of a serverless option with this node group settings now. So what it simply means is more or less like when you select this particular option now, the necessary things your worker node needs to actually make use of to make them look like a proper worker node. With this particular option, every details like your kubelet, your kubeproxy, your container, I think it's container D, everything is actually set up in this particular node groups. Yeah. So automatically your node groups become a proper worker node that can actually interact with your Kubernetes cluster. And also when it comes to issue of like you want to like auto scale things like that, that you need to actually do some other setup for that. While for a Fargate profile, so for Fargate profile, when you use this Fargate profile, so that means you're setting up your worker nodes. But in this particular one, anytime Fargate provisions worker nodes for you. So the only thing you'll be concerned if your worker node is more. If you just the good thing about Fargate profile is more or less like as, as much applications you're actually deploying to your worker nodes, automatically Fargate actually does the provisioning of more worker nodes to actually handle the workload. But for this node group settings now, so that means automatically you need to actually specify the minimum worker node you actually want to have working basically. So the moment you have a lot of loads coming up, maybe like a lot of applications being deployed to your worker nodes, so automatically you need to set up some cluster to scalar setups so that automatically you provision additional worker nodes to actually be able to handle the workloads coming. But for Fargate workload is becoming much on this worker nodes. So at the moment it happens like that. So EKS, so for Fargate itself, it actually auto scale itself by itself. So there's no issue of if you are getting more or less like running out of maybe resources on your worker node. So it does its own automatically. But for node group itself, you'll be specifying the number of nodes you actually worker nodes you actually want. So at the moment you have applications that is more or less like maxing up your worker nodes, then you set up some auto scaling setups and also provisioning another set of worker nodes to actually handle the workload. So let me confirm if this has finished setting up. Okay, I think we are done here now. Okay, fine. So now we've actually, our EKS is actually set up now. So this is our endpoint certificates to actually use to connect to our cluster. So now let's just try to, okay, the name of our cluster is EKS Cluster here. So now we'll just try to connect to our EKS cluster. AWS. Okay, this is okay. For us to actually connect to our EKS cluster, we need to run some particular command. So AWS EKS update kubeconfig. The name of our cluster itself is EKS cluster, and the region where our EKS cluster is deployed is US East 1. So now we just need to just run. Let me confirm. Okay, it's yes. Okay, so now we just need to just confirm and just enter. Okay, cool. So now we have we can now connect to our cluster itself. So kubectl gets pod. Fine, there's nothing there now. So let me just run kubectl cluster info. Okay, fine. So from this command I ran, kubectl cluster info now. So you can see that Kubernetes control plane is running at this endpoint. So this particular endpoint is the same. This is 3C418. Is the same with what we actually have here. So this is the endpoint we're actually communicating with the Kubernetes cluster now. So now the next thing for us to now do now is to provision, to set up our worker node itself. So what we need to actually do now is to create, we need to actually go to compute. So from this compute option now, it's where we actually create our worker nodes. So we'll be making use of this option called node groups. So we select add node group. Okay, now, so for this add node groups now, so we can just call this EKS worker node. So we need to select the role we actually created earlier. So the actual node created earlier was worker node, EKS worker node. EKS, that's the role we're using. So, oh yeah. Okay, now, so yeah. So now this is the configuration for our worker node itself. So you'll be looking at, okay, fine, for the worker nodes now, what kind of configuration do you want to select? So it just depends on kind of configuration you want. So this is what we have here: Amazon Linux, capacity type on demand. This is a T3 type of instance. The disk size is 2. So that means if you want you to have like 3 worker nodes when you launch your worker nodes, so you set it up. If you minimum, maximum, so in case you are scaling up your worker nodes, you can actually specify the number of nodes that you can actually max out so that you don't exceed some necessary cost. So this is the settings for my worker nodes here. So you click on next, you automatically, so this is our subnet that we have for our CloudFormation setup. So this is it here. Private subnet, public subnet. We'll click on next. Okay, so looking at the role configuration, the role I made use of, my compute configuration itself. So type of instance, the MI type, instance type, disk size, the node configuration for scaling up, that's desired, that's 2, minimum 2. Then next, we click on create. So now we can actually just try and see, okay, for it's actually creating at the moment. So this is it at the moment. This is EKS worker nodes. We selected 2 desired worker nodes to be set up. So we can actually just come here and try to see the C2 instance while it's being provisioned. Okay, so at the moment, these are the 2 worker nodes here. Instance type T3 medium, T3 medium. So we actually wait for it to actually finish setting up. Yeah, so lastly, I actually forgot when we run this kubectl command. So on my local machine, there are certain things that needs to be on my local machine. So that means number one, I must have set up my AWS credentials on my local machine, and also I need to have installed kubectl on my local machine. So kubectl command is what I'll be using to like interact with my Kubernetes cluster. So having your AWS set up, your configurations, that means something like this. So you provide your credentials so that you can actually be able to connect to your AWS account with the necessary permissions, and also the kubectl command. You need to actually ensure that you have kubectl installed on your local machine, and be it Mac or Windows. So now let me try and see. Okay, that's not. Okay, it's showing ready here at the moment. So these are our 2 worker nodes here. So let me confirm if it has finished provisioning. Okay, I want this status check to show that it has finished initializing. So now that we actually have our worker node set up now, so automatically with the setup we did, our worker node be able to like interact with the control plane itself. So we can just do a little demo of just deploying a small Nginx application and seeing if we can be able to see it on our URL. Okay, it's ready here. Okay, cool. So these are worker nodes, and these are our 2. These are 2 worker nodes with the stated configuration itself. T3 medium. The node group is EKS worker node group. So now let's just run. Okay. Now we can just deploy a little. Okay. So let's. Okay. We have this deployment here. Okay. So we're just going to actually just deploy an Nginx application on our Kubernetes cluster and see how it looks like. So also let us just check the service itself. Okay, fine. So we have a deployment, um, two replicas itself. The image is Nginx. So by default, the proper way of connecting your deployment file to your service, making use of match labels and selectors. So we have our match labels here. This is app Nginx. So this values needs to be the same on your service also. So this also is selector app Nginx. So now let's just apply this to let's apply this deployment and service file. So that's deployment. So let's try and run for service also. So let's try and see. Keep it. Let's try and see if our pods are actually running. Okay, we actually have two pods running at the moment now. So we can actually do a port forward. Keep still port forward. Okay, get service. Okay, keep still port forward. So we are port forwarding we're actually port forwarding this particular service so that we can actually see it on our to actually connect it on our own URL on our browser. So port forward service. This is the service that the deployment is actually using Nginx service. So port 80. We'll be making use of port 80 on our system here. Okay, so let me just copy this. Okay, fine. So this is the Nginx that we deployed now. It's actually showing on the browser. So that means everything is actually working fine here now. So this is the whole setup here. Setting up of the cluster from the worker node and the master node itself. So the worker node is able to like communicate with the master node, and we have two pods actually on our worker nodes at the moment. So this is it. It's working fine now. So this is one of the methods of setting up an EKS cluster. So this is more or less like just the UI setup, and also without going through this hassle of going through this hassle of the UI stuff, we can actually make use of EKS CTL also, which is just a simple command that you just use to create your clusters. So I actually have a little file here, a file that displays how to actually. Okay. Okay, fine. So this file itself, cluster.yaml file. So if I actually want to use EKS to create my EKS cluster, I can make use of the EKS command line command itself. So this is one that's like a small configurations of what I actually need. So with EKS CTL, when we run this command, it automatically creates use cloud permission to create a private subnet, a public subnet also. The whole VPC thing we actually need. So I don't need to set it up. With EKSCTL, it actually runs, does the creation very well for us. Then automatically, and the little configurations we actually specify here, it's actually going to actually provision the necessary things we need. So I think that's just all. So that's just the basic way of just setting up an EKS cluster manually.
Oh my god, my audio went out again. Hi guys. My audio went out again for a while. I'm sure you understood what Taiwo has done. That's like an hands-on session on how to create an EKS cluster. Thank you, Godwin, for letting me know about my audio. I had no idea. I was just talking. So we've crossed past the hour of 9 o'clock. So this is past our time. What we are going to do is, if you have any question, just paste your questions in the comments, and then we'll have Taiwo answer that quickly. The questions. All right, so no questions. So someone just said they can't hear me. Can you hear me now? Please, if you can hear me now, just okay, great, fantastic. All right, so um, I've put Taiwo backstage. So if you have any questions, just paste them there. Since we don't have any questions, what we're going to do is I'll just announce the we are having a beginner session on Wednesdays. So we have beginner sessions on Wednesdays and advanced sessions on Saturdays. So on Wednesdays we take you through the basics of cloud computing, and then we introduce you to cloud, introduce you to Linux, introduce you to bash scripting, and the necessary foundations for you to be able to build your own project, right? So, okay, so someone just said they can't hear me. Please, if you can hear me, just notify in the chats. Okay, so there's okay, fantastic. So there's one question there for Taiwo. Taiwo, let me bring you back up. Taiwo, can you hear me? Are you there?
Y- Yeah, I can hear you.
So someone said, "Thank you, Taiwo. Can you do a little explanation on the EKS CLI file to create the cluster?"
Okay, so the EKS is called EKS CTL. It's more or less like a simple command that you can actually just run on your terminal to create a cluster. So can I just let me just show you? Can I share my screen? I just show you some commands.
Taiwo, we're out of time, so
Okay,
just
fine.
just do some
Okay.
explanation. We'll
Okay,
continue
fine.
next week.
So what the EKS CTL command does is more or less like just create. If you just want to just create like your cluster with just minimum configurations. Just like what I did earlier, whereby I was creating VPC stuffs. So with that one, you can just with the moment you have the EKSCTL on your terminal, when you just specify EKSCTL create and do dash dash help, it gives you different options. But to actually give you a very easy explanation, just type this EKSCTL on your browser. It takes you to it takes you to this eksctl.io website. The first page you will see the command you can actually just run to create your cluster. That was the file. That was the file I actually created there. That I just specified little configurations I actually want to make use of.
Okay, so I think that answers your question. I'm just going to paste the link in the chat there. Yes, eksctl.io. You can do some more research on it there. Any more questions? Any more questions? Okay, so no questions. We have our advanced sessions every Saturdays from 8 p.m. and we have our beginner sessions every Wednesday. So the reason why we have the Saturdays session is to, like I said earlier, to help you gain hands-on knowledge and increase your portfolio. Today we did do the projects for increasing portfolios, but we showed you how to create an EKS cluster. So from next week, we would now have to deploy, to that cluster. So I would need you to watch this session again so you can follow up. Watch it again, practice it, create your cluster down. Well, just know how to create the cluster. So once we get here next week, Saturday, same time, same place, we would now deploy an application to that. With that, without further ado, I'll say thank you so much for attending today's session. Trust you had a wonderful evening and please enjoy the rest of your weekend. Goodbye. Bye bye.